In this video, we are going to discuss the basics of electricity. Electricity is a type of energy that can build up in one place or flow from one place to another. When electricity gathers in one place, it is known as static electricity. The word static means something that does not move. Electricity that moves from one place to another is called current electricity. In this video, we will discuss the basics of static electricity. In order to understand electricity, we need to understand the parts of an atom. Here in the center is the nucleus, and it contains the protons, which are positively charged atomic particles. I can see there are 1, 2, 3, 4 of them, which lets me know what element it is. If you look on your periodic table, the element with atomic mass of 4 is beryllium. So that's the model that we have here is beryllium. Also inside my nucleus, the center part here, are neutrons, which are the uncharged atomic particles. Also in the atom are the electrons, which are the negatively charged particles. If this is a neutral atom, there will be the same number of electrons as there are protons. The electrons are out here in this outer portion, and they orbit the nucleus. And for electricity, what we're really concerned about is the outermost ring of electrons called the valence electrons. The movement of positive and negative charges is what's responsible for static electricity, which we'll talk about in this video. In our next video, we will talk about the movement of electrons from atom to atom, which is current electricity. So let's talk static electricity. Static electricity often happens when you rub things together. Have you ever walked across a carpet and felt a slight tingling sensation from rubbing your shoes against it, then touched something metal like a doorknob or a faucet and felt a sharp pain in your hand or even seen a spark? That is an example of an electric shock. When you walk across the carpet, your feet are rubbing against it. Your body gradually builds up an electric charge, which is the tingling you can sense. When you touch metal, the charge runs instantly to earth, and that's the shock you feel. Electricity is caused by electrons, the tiny particles that orbit around the edges of atoms. Each electron has a small negative charge. An atom normally has an equal number of electrons and protons, the positively charged particles, so atoms have no overall electrical charge. Suppose you rub a balloon on your sweater over and over again. As you move the balloon back and forth, you give it energy. The energy from your hand makes the balloon move. As it rubs against the wool in your sweater, some of the electrons in the rubber molecules are knocked free and gather on your body. This leaves the balloon with slightly too few electrons. Since electrons are negatively charged and you have too few in the balloon, this makes the balloon slightly positively charged. Your sweater, meanwhile, gains these extra electrons and becomes negatively charged. Your sweater is negatively charged and the balloon is positively charged, and opposite charges attract, so your sweater sticks to the balloon. Electrons can also be influenced to move in a coordinated fashion through a conductive material. This uniform motion of electrons is what we call electricity or electric current. The amount of current in an atom, generated by an atom, is based on the number of electrons in your valence shell, or this outermost ring here. Some hold tightly, which means that it is an insulator. For example, if you have 5 to 8 electrons in this outer ring right here, you will have an insulator. Some of them are more loosely held together, as in the case of conductors, as in copper. And if you have 1 to 3 electrons in your valence shell, then your material is considered to be a conductor. So less is more for electricity. Electricity is created as the electrons collide and transfer from one atom to another. This is how we have electrical current, which could also be called dynamic electricity in contrast to static electricity, which is the unmoving accumulation of electric charge. Just like water flowing through the emptiness of a pipe, electrons are able to move within the empty space within and between the atoms of a conductor. The conductor may appear to be solid to our eyes, as with any metal, but any material composed of atoms is mostly empty space. Substances that allow electrical charges to pass through are called conductors. All metals such as silver, copper, aluminum, iron, etc. are good conductors. So is water. Other substances called insulators do not allow charges to move freely through them. Some examples of insulators are hard rubber, glass, silicon, and wood. Electricity can travel through something when its structure allows electrons to move through it easily. Metals like copper, seen here, have free electrons that are not bound tightly to their parent atoms. These electrons flow freely throughout the structure of copper, and this is what enables an electric current to flow. In rubber, however, the electrons are more tightly bound, and there are no free electrons, and as a result, electricity does not really flow through rubber at all. Conductors that let electricity flow freely are said to have a high conductance and a low resistance. Insulators, on the other hand, do not allow electricity to flow and are the opposite. They have a low conductance and a high resistance. So, since there are between 1 and 3 electrons in the valence orbit, copper is a conductor. And why is this? Because of the few number of electrons that are in orbit in this valence electron shell. Understanding the difference between conductors and insulators is really important when dealing with electricity. Electricity is very dangerous, and small amounts of electricity can be harmful and even fatal. So we want to stay away from water and metals when there's a lightning storm or when you have electrical current present, because that's going to allow the charge to flow more freely. You can see here on these pair of pliers that we would use to work with electrical equipment, the conductors are the metal parts. So we see here in the wires and here on the end of the pliers. And then the insulators, so in order to make these tools safe, we have coated the wires in plastic because it's an insulator, and also coated the metal handles of the pliers in plastic because it's an insulator. Now that you know some of the basics for electricity, both static and current, let's take some time to play with static electricity and investigate some of the properties. Take some time to play around with the simulations and learn more about how the charges react to each other.